everybody. My name's Alex Muller. I am co-founder and president of Savvy AI. We are a machine learning company that helps almost any company deploy machine learning applications. A little bit about my background. Before starting this company, I was chief product officer in a machine learning division at Synchrony Financial, and we spent a lot of time building machine learning applications. One of the things that we learned is there's a really large gap between the business expectation and the data science team expectations. And so what I want to do is take a moment and talk to my data science friends out there and tell them about the gap and maybe also discuss some techniques to resolve that. So let's start. So one of the things that happens often as a company, and I know certainly some of the companies I've been part of, they've had this, they started to build a data science team. And they're like, oh man, we're just going to lock these people in a room. They will figure it out. Don't worry. Everything's cool. No problem. The data science team's got that. And so they hire this data science team, and then immediately things start to go off the rails. And I'm not sure if you've seen that at your company, but I'm just going to go through some scenarios, and I'm sure you'll find that some of these are quite familiar. Let's start with some expectations. So let's say you hired this data science team, or you're a part of that data science team, really proud of the work you've been doing on machine learning, and you built some predictive models. You built a predictive model that would tell you the probability somebody would accept a coupon offer, or you built the predictive model for a finance institution of the probability somebody's going to charge off their loan, i.e. not repay their loan. Or maybe you work at an auto dealership and you built a machine learning model that determines what is the likely margin for selling that car. And great, you've done all the math, you've worked through scikit-learn or whatever other platforms you're using, and you've built your predictive model. And then you walk over to your team, and the business team, and I'm talking about like the CEO or the VP of marketing or the VP of sales, is like, okay, great, good job building those predictive models, but how does that help me with growth? Or how does that reduce risk for me? Or how does that increase my profit? And then you shake your head and like, oh, I see the issue. But they're not the only ones. Even your product team, right? And we're talking about your product manager who gathers the requirements and puts everything into Jira and Monday and all the product tools and decides to like create all the epics and works with the agile team. And they're sitting there going like, okay, I see that you have probabilities for various things, but can you tell me which offer to show? So which coupon promotion do I show this particular user? Yeah, I see you're telling me what the probability of charge off is, but I really want to know, should I accept or reject this loan transaction? And I see you're telling me the probability of a specific margin, but what I really want to know is what price to price this car at. Even the engineering team will go to the data science team and be like, totally love it, totally understand what you've built there with predictive models. I also am an engineer and write software and also share a love of Python code, but really you're not helping me because the product team set these requirements. They want to show which offers to show, and you're still giving me probability. So can you give me what I really want, which is basically an API with a JSON response that specifically tags each offer ID and rank orders them? Or could you just give me a different API that is a Boolean that is accepted or not, true, false, so I don't have to think about it? Or just deliver the API with the recommended price. And what you start to realize is predictive models in actual usage of the models are two radically different things. And that there's a really big expectations gap because that engineering team, that product team, that business team is looking for something that you are actually not delivering. And to deliver it, this is what you and them probably didn't really put together. When you are a data science team and you're trying to deliver on a machine learning use case that is trying to come up with a decisioning of what offer to show, there are elements of that entire workflow, right, in data pipeline that are data science oriented, building predictive models, even productionizing those models. There are other elements that are DevOps, right, where it's, okay, we're going to host the models. And then there are third elements, which are objective functions, which may use one or more models to come up with to a decisioning framework. But you can't stop there. In addition, On top of any decision framework, you want to have business rules. You may say, hey, I'm going to show various promotions, and I'm going to show clothing promotions to these people, and I'm going to let the machine learning decide who sees what promotions. But those 19-year-olds who are looking at the beer ad promotions and constantly clicking on it will teach the machine learning model that 19-year-olds want to see beer ads. But the problem therein is they're not supposed to buy the beer. In which case, the right thing to do is have a rule. If your age is less than 21, do not show these particular ads, no matter how much the machine learning will learn that those are good ads to show. And when you think about all those other pieces of software that have to be created, including the data pipeline that needs to be made continuous and recursive, now all of a sudden you realize that there's a lot of non-data science software that needs to be built. And whose job is it anyway? When you run into this problem, I promise you, you are not alone. Almost every single team I've worked with for Fortune 50 banks have this problem. The data science team is delivering on what they think their role is, but the rest of the business thinks their role is actually something else. To the point where when Gartner started asking companies who are working in AI, what are your 3 top challenges? They're like, they don't know where to start, because in communicating with the data science team, they're losing the forest for the trees. And the data science team wants to talk about things like whether convolutional neural nets or random deep forest models are better in this particular application. These guys are trying to figure out, like, where would I use this in the first place? And then even the ones who built models often have had their data science teams focus on the building of a model, and the model lives in isolation, probably on somebody's laptop, and is never connected to production software. And then even when it is connected into production software, there is so much fear about it and so much pressure that the model usually stays static, doesn't continue to learn, and finds itself with some drift and completely irrelevant over time. These 3 issues are true almost everywhere. So crossing this chasm, meeting this expectation gap, resolving these issues requires skills. And oftentimes they are not typically the skills that machine learning enthusiasts and data scientists have out of the box. But let's put this into a framework that we can now discuss. First of all, if you find yourself on a data science team, maybe ask yourself how you got there. How did the company choose to hire you in the first place? Someone made the decision to allocate budget to create a data science team. What was their motivation? Maybe their motivation was because they're in a bank and the other competitors talk publicly about their data science team, so they need one as well. Maybe the motivation is just that the board of directors thinks AI is the future. And that means that the first step is you hire into those roles. If you're lucky, you've been hired because there's a specific and expensive problem they need to solve. And that's clear. At least that gives direction. But the question is solving one single use case really a job for a team, or is it just a start? Perhaps a company is just planning correctly and thinking future-proofing, and they're just like, well, in 2010s, we hired a bunch of DevOps people managing our cloud software. So in 2020s, we're going to hire a bunch of data science people handling our machine learning software. Or, and sad, but probably true many times, the CEO used ChatGPT, came back into the boardroom and said, we're hiring data scientists. Very rarely, and I mean almost never, has a data scientist been formed for the right reason, which is somebody at the company defined a list of needs that can be addressed by AI or ML. And that list of needs then became the roadmap for a data science team. But once you've understood the motivation, the second thing is to understand the stakeholders. You're on this team for a reason. You're on this team to deliver value. Who do you deliver value for? And it helps to understand their language. So, we want our AI ML to help find something or someone new to sell. Okay, that should start turning your wheels about where predictive models can help identify higher probability selling targets. CFO say, hey, we want our AI ML to save us money. Okay, maybe different wheels, helping them understand automations or opportunities for automations in AI. The CEO may have something completely different, which might say, like, look, I want to look innovative to our board in the Wall Street. And I want to use AI to tell the story about our company and how it's moving into the future. The CPO might just say, hey, I want to make my teams more productive, and I want to use AI ML to do it. Or the product person is just sitting there like, look, there are probably 50 places in our product where we could add things like personalization or optimizations, or take away A/B testing and replace that with various AI. So the product team's also sitting there about all those different use cases. So once you understand their stakeholder, then you can start to do something. This is probably, if there's any slide that you're going to screenshot, take away, and talk about, it's this. How do you explain machine learning use cases to non-data science people? And so, look, this is not every use case in machine learning. I'm not talking about self-driving cars here. The vast majority of you who are looking at this presentation are probably working in either a consulting or direct company who is doing something with data in an operational kind of way. And in your case, your use cases almost always fall into one of these 6 buckets. Is your machine learning trying to make a decision? In which case, the simple explanation of that is like, hey, it's picking the best option. Think like a multiple choice test. Picking the best option to meet a goal. And as an example, it's like, okay, let's pick the best processing facility to expedite delivery of some goods. Great. Very simple framework to think about that. A recommendation. Hey, is very similar to a decision. It's recommending the best option, but this is usually human reinforced learning. It's recommending the best option with the goal of being accurate. Maybe it's suggesting the best product to promote to a particular user in a personalization use case. Maybe it's just suggesting the best course of action. Usually the slight difference between decision and recommendation is how you're reinforcing it. Classification. When you're explaining like, what's a classification use case? This could be just, is it a cat or is it a dog? Like you've got data, you've got unstructured data, you got audio, you got video, you got imagery, and you're classifying prediction. Now, a lot of the prediction is the underlying machine learning engine that powers almost everything here anyways. But from a non-data science perspective, prediction is different than decisions. It's just like going to give you some inputs. Can you predict next month's sales? Or if a client's likely to churn? Generative. Now, this is new, but since you're on the data science team, you're probably going to be asked about this. So the really easy example is that it creates text or images from prompts, i.e. write a sales email that reminds someone that about our product enhancements. And it will literally write the email, probably starting with, I hope this email finds you well. The point is generative is a hot topic, and it's good to have a simple explanation. And then the last one that you may often run into is natural language. And you explain that, like, look, this is going to take a unstructured text or audio and turn it into an action. Like, what's in my account seems like a vague sentence most computers wouldn't understand. But with some NLP software, you realize, oh, if what's in my account is in the context of a banking application, this really should query the user's bank balance. Once you understand the different use case types or category of use cases, you can get a little bit more specific into what a client's trying to do. And then you can get into a prioritization. The people who are going to love this slide, if you're on the DS team, is your product team, because this is how they think about almost every feature. So they'll go in with you and they'll say, hey, what can we do? Okay, we're going to make a decisioning or recommendation stem that's going to like optimize the user flow. Great. You can see that it's a decisioning one. It can have some rules, but then what's really important is that we determine the value, the importance, the risk, and the difficulty, and we score it. Why? For machine learning to be successful, it's not about one use case. It's about a series of use cases, because this isn't about just one thing at your company. It's about adding a capability across your company. And I think here, what's important is when you're scoring it. So important is kind of like how tightly does it align to the strategic plan of the company? Value is how much economic value does it drive? Risk is if this thing goes live and it makes a mistake, what's the downside? And difficulty is, yeah, it may not even be that hard to build the machine learning itself, but the difficulty might be in the data collection for it, might be in the implementation. Maybe it requires partnerships with other vendors to create the full user experience. So that difficulty is really like how hard to get this use case into production. But the real thing next you do is let's say you prioritize it, great, but now you got to break down what is the use case and what does it mean? Now, here is where that gap continues to be quite large. So for instance, if you're talking about one of those decisioning use cases that we were talking about before, like determine what homepage ad banner to put on your website, the business people are just saying, okay, so you're going to ask my magic AI box, what's the best option? And the AI box will say the best option is X. Great. That seems simple. You should be able to knock that out in a week. But the problem is, it's not simple. And in fact, 90% of making that decisioning use case work has nothing to do with machine learning models. That piece of this is lost on everybody. And what happens is that as a data science team, you're working on the first 3 steps, you think your job is done, and you think the next 4 steps belong to the agile or product team. And they're like, no. This is part of the function you said you would provide. And now there's this is where 90% of data science projects fall on their face, because to actually use the model, you got to build out all this other software. The objective function that recursively runs through the model predictions to come up with the best ranking option, a decisioning rule set that lets you control the options, performance monitoring, data pipelining, continuously republishing the models. All those different steps require time and effort. And oftentimes, they are not the data science work you thought you were doing when you entered the company. So you got to ask yourself, is your job at this company to do data science? Or is your job to deliver on an AI ML use cases? If you are at a company where they're like, no, really, your job is only to do data science, and there are companies, like I imagine Google sits in that regime, then great. But everybody else, it's this other thing, that your job isn't to do data science, it's to deliver machine learning and AI use cases. And let that sink in, because unless you deliver those use cases, no one cares at all about the R squared of your model. They don't care about that you've been able to reduce the RMSE by 50%. None of that matters. What they care is this machine learning doing those decisions, recommendations, predictions, classifications, or other functions that we are looking for? What does an ML delivery team look like, and how is it different than a data science team? Well, there are 2 options here. Let's go with option A, is transform your team into an ML delivery team. What does that mean? That means I know you think you hired a bunch of data scientists to do it, but really, you probably want 2 data engineers for every data scientist you have on your team, because there's many more hours in data engineering and building data pipelines and writing queries, centralizing data sets, than there is in running and building models. You'll also need full stack developers who are going to build out the business logic, connect and create UIs for operational management. You'll need DevOps and SREs to manage the hosted software environments and the ML hardware you're using. And then, of course, you still need data scientists to build and train models that are used inside the ML app. And I didn't even talk about a project or product management role that oversees the delivery of these ML use cases. And then there's option B, and there are tools out there that can help you. You don't have to do all this from scratch. You can find an easy to use tool with an interface for ML apps. You can contextualize those ML models to be goal-oriented. They can be embedded with decisioning. They can auto-deploy and be served via a REST API, JavaScript, or even no code, and host their own endpoints. And those tools, the good ones anyways, can provide continuous learning. And with that, that's my minor plug for Savvy AI. But either way, whether you go option A or option B, you have to focus on the delivery of the ML app and not the delivery of the data science. And with that, thank you very much. I've appreciated this opportunity.